All right, good morning, everybody. It's 9 o'clock, so let us go ahead and get started. As you can see on the screen, the topic for today is mainly related to survey research, but in order to talk about surveys, we need to revisit the information on sampling that you all worked through a couple of weeks ago. All right, so here's our plan. We'll start off, like I said, reviewing the materials on sampling since surveys rely on samples, and we want to make sure we understand the difference between probability and non-probability samples, as well as different types of probability sampling techniques. After we do that, we'll spend some time talking about different kinds of experiments, including survey experiments related to this week's material. Last time we met, we introduced the concept of the classic randomized experiments, but in most social science research, save some behavioral economics, most of our experimental methods don't quite work that way. They don't take place in a lab setting. They happen somewhere out in the real world in people's natural environments. And then after that, we're going to go over survey research methods, talk about what good and bad survey questions look like. And then at the end, I'll discuss Lab 3, which is the next upcoming assignment. And we'll do a short little participation activity so that we can practice interpreting quantitative data in graph form. Okay, and before we move on to the materials, just a quick announcement. Yesterday was the deadline for part 1 of your research paper. When I checked this morning, I was surprised to see there were quite a few people who had not turned it in. Just the research project overall is the biggest component of your grade in this class. Unless you get a 100% on every other assignment, it will be impossible for you to actually pass this class and get graduation credit if you don't complete that part of your grade. So I mentioned in the syllabus, at least with the research paper, I'll take late submissions. I'm going to dock you points for each day that it's late. But if you didn't turn something in, please get in touch with me soon so that we can figure out a game plan for getting part 1 done so that you can successfully do part 2. All right, so into our recap of sampling from a few weeks ago. You were introduced to 2 different concepts. One is called a sample and one is called a census. Who can briefly remind us what the distinction between these 2 different ways of collecting observations is? Mm-hmm. Yep, bingo, you got it. Population is just a sample is just a chunk of the population. We ideally want it to be a representative chunk, whereas the census is trying to observe everything in whatever population you're interested in. So when we say population, we usually think about people, right? Population of people. This is certainly the case if we're doing survey research, but if the unit of analysis that we're interested in is the country or the country year, as is common in a lot of institutional research in comparative politics, as well as in international relations, depending on how you define the population, it's entirely possible to observe and analyze the entire thing. So, population studies often examine things like wars, international agreements, political institutions, regimes, but when we're trying to observe people, this gets a little trickier. So when we're studying behavior, let's say individual level outcomes, as opposed to the country year level outcomes that you were all looking at in lab number 2, country year was the unit of observation. In behavioral studies, we usually rely on samples. So in this instance, if we're doing behavioral studies, trying to understand something like political ideology, attitudes, political engagement, why might a sample be better than a census? What are some of the pitfalls of trying to conduct a census level analysis of individuals, say in a place like the United States? Yeah, Kate. Yeah, so try as we might, even if we claim to be observing the entire population, often our methods fall short and we're not able to do this for a variety of reasons. One of those might be response bias, right? So, some people just decide not to participate in the study. What else? Kind of related to that point, what other problem might that create for us?
I think the large geographic location of the United States, it would be very difficult to gather every single person in such a large geographic location.
Yeah, so we've got feasibility concerns, right? These studies that we conduct, they don't just happen for free, right? They take a lot of money, and as I'll mention here in a few minutes, even even the big public opinion samples that a lot of projects rely on. These are, conducted every 2 or 4 years. They're multi-million dollar projects, very, very expensive, even if we're just analyzing a sample. Then there's one more potential pitfall. Again, it's related to this idea that it's hard to capture everyone in the population. Just from a causal inference point of view, why might this be problematic? Anybody on Zoom? Said we're trying to generalize to the entire population.
Could it possibly do with the leaving out the population of the homeless
Yeah.
and undocumented?
Yeah, so we're gonna have, we're gonna say that we're trying to study a census, but what we're gonna end up with is a non-representative sample ultimately at the end of the day. So for all of these reasons, it might be better just to collect a sample of maybe 1,000 to 3,000 people. You can carefully draw the sample, make sure it's representative of all groups that you're trying to generalize to, and the data usually is of higher quality in the end, which might seem counterintuitive, but it's not. So like we said, population studies, at least of behavioral outcomes, individual level outcomes, these often miss certain groups of people, right? And a well-drawn sample of sufficient size, that's really key here, and well-drawn means that it's representative. This can be more representative of the population than attempts at conducting a census. All right, so given that it's probably better just to collect a high quality sample to analyze rather than trying to observe the whole population, let's walk through some of the different ways that we can actually do this. So we're first going to look at what we call probability samples. Probability just means that everyone in whatever population we're interested in has some known probability of making it into our sample, right? So the first one you were introduced to was just the simple random sample. This is kind of the most basic idea. Who can explain what goes on here? How do we do this? There's first a requirement that we have to meet, and then we have to do something. Is that one like where you decide which different populations or groups you're going to draw from? Yeah, so that's a different type, but this one's even more basic than that. Who remembers? So we're going to start off, we have to assume that we have, it's like drawing names from a hat, right? But we have to have all of the names in the entire population before we can do that. And although this is called a simple random sample, it's often unfeasible to have, every instance of an observation in whatever population we're interested in. But if we assume that we do, we can just think of putting everyone's, the names of every single adult in the United States into some sort of hat or, spreadsheet or something, and then just randomly picking until we get to whatever number we want our sample size to be. So if we want to analyze 2,000 people, we're going to put all names into the hat, draw out 2,000, and we've got a simple random sample. And it's a probability sample because everyone in the population has the same known probability of making it from the population into the sample. So like I said, in order for these to actually work, for us to be able to draw good causal inferences from them, the simple random sample we draw, it has to be sufficiently large in order to truly be representative. And the reason for that, especially if you think about a potential sampling frame of 300 million US adults, if you're only picking 100 names out of that, there's a pretty high chance that you're going to miss certain groups that you would want to be included in the sample. So we might think of 1,000 or 2,000 as being a sufficiently large simple random sample. And then the next one is called the stratified sample. This one's kind of like simple random, but it's got an extra step. Who remembers what this one is? And this is designed to kind of help us overcome that potential problem that we might miss certain groups. Yeah, James.
So you basically do a simple random sample from each group that you have.
Yeah. So you decide ahead of time whatever groups you need to make your sample representative. We might stratify on things like sex or gender, race, religion, who knows? The researcher's going to decide. And the first thing we have to do is we still have to have a list of the whole population in order to stratify that list in the first place. But we're going to take that list, we're going to divide elements, right? Elements are whatever's making it into our sample. Usually we're talking about people, but not always. And then you're going to just randomly draw from each of those groups until you get, whatever number you need to have the percentage that you want in your sample on certain characteristics. Right, so like I said, you'll have the list, you'll draw randomly from each group until you get the desired proportion, generally the same proportion as in the population, but not necessarily. If, say, you want to study attitudes of certain minority groups, you might overdraw on that, right? And there's weighting techniques in the statistical analysis that help you, generalize to the population, but you might want to have a sufficiently large sample of a certain subgroup, right? And then the final one is what we call the cluster sample. This is actually what most big survey projects use. And the reason for that is because you don't actually need a list of the entire population. Instead, you do something else. What do we do when we cluster sample? And again, it's easiest to think of this in terms of survey research. So if we were trying to draw a cluster sample here in the United States, what might we do?
Hello.
Yes, tell us. What might
you divide them in subgroups, but those subgroups have similar characteristics.
Well, that sounds a little bit like a stratified sample. We are going to start by dividing people, but instead of dividing on characteristics specific to the individual, we're doing something a little different. Any idea? Yeah. Location, yeah. So that's what we're dividing people by. So the reason that this doesn't require an entire population list is because first, like I said, think if doing this in the United States, the first thing we're going to do is we're going to randomly select a certain number of states. Maybe we're going to select 10 of them out of 50. And then within each one of those states, we're going to divide it up. Maybe we're going to divide it by county. And in each of those, we'll draw maybe another 10 or 20 counties at random from each state. And then we just keep going down and down and down until we get to the neighborhood level. Once we get to the neighborhood level, or maybe the census tract, this is where we need a list, usually of all the households. And that's going to be the lowest level. We're just going to randomly draw households, maybe go knock on the door, randomly select someone in that household to take our survey. And like I said, because of that, it's a little more feasible because you don't have to be able to identify everyone in the whole population, just within whatever the lowest cluster is that you're going to draw elements out of. Exactly. Yeah, so those were all probability samples. Ideally, this is what we want to be working with because these are high quality. Usually we can assume fairly representative data. It's going to allow us to generalize to the whole population. But oftentimes researchers will rely on non-probability or what we call convenience samples because collecting these high quality probability samples is very, very expensive. The American National Election Study, for instance, which I talk about all the time in this class, they're starting in the last 2 waves to experiment with conducting this survey online. But traditionally it's conducted face-to-face, someone from the research team, they go knock on doors, they keep going back until they get someone to take the survey. It's a long survey, so they have to compensate people for it. And I think the estimates from the 2016 survey that was conducted said that something like $4,000 per respondent was what the ultimate cost was to get that high quality sample. And there's like 4,000 people in the ANES. So it's millions of dollars, very, very expensive. Most researchers don't have the funds or the opportunity to conduct those kinds of studies. Instead, we rely on non-probability samples, which in certain instances, depending on what we're doing with them, can be okay. This is pretty much the model that all of those opt-in online surveys that you see use. So if you take YouGov surveys, you get an email from YouGov, you decide whether or not you're going to click on the take survey link. So that potentially creates some problems, like I said, for causal inference. Why might this be problematic if we're trying to generalize to the whole population, if we're relying on people opting in to take our survey? Right. And we see that response rates with these are actually pretty low, sometimes less than 10%. So if only 10% of the people you even invited are taking the survey, there's a lot of questions we have to ask about who's actually taking the survey and how representative it is. Yeah. So another thing is, most of these, they're online surveys. So we're going to miss key demographics for people that don't have internet access. We're going to miss people in rural areas. We're going to miss people in lower income households. We're going to miss older individuals that don't necessarily have a computer or a smartphone to take these surveys on. And then we have to worry about this thing called selection bias and ask ourselves whether or not certain types of people in the population are just more prone to opt into these surveys in the first place. A lot of times we see that people with higher levels of education, maybe more political interest, more free time, are the ones that are more likely to take these surveys. So if we're drawing causal inferences from that, we have to note that limitation because we're not actually generalizing to the whole population. And a good example that I would say in political science, a lot of researchers are moving away from Amazon's Mechanical Turk platform to field surveys and pay respondents for them. But for probably, honestly, for most of the time that I was in grad school, this was kind of the go-to method. I think I've published 3 different studies by now that all relied on Mechanical Turk samples, but it's getting increasingly difficult to just publish a one-shot MTurk study. And the reason for that is these samples, they're not representative. So we know from research that when we compare MTurk samples to the population at large, they're more educated, they're more female, more liberal than the broader population. So all of these, again, they can create potential problems for generalizing. But as I mentioned here, this doesn't mean that we can't use them. We just need to be really specific about limitations in drawing causal inferences. And as we'll see here in a few minutes, because of the way experimental methods work, it's sometimes less of a problem to use a convenient sample for, say, a survey experiment than just an observational study where you're looking at relationships between different attitudes or looking at descriptive statistics. And another way we can eliminate some of these problems, but not the big selection bias one, is that in convenient samples, we can use quotas. So again, we'll think about whatever we think important characteristics are for a political science survey. Maybe, again, that's something like gender, partisanship, race, religion, any of these things. We'll say we want, a certain percentage of our sample to be women. After we reach that quota, we're not going to let people continue in the survey. We're just going to open it up to, the other 50% men that we want to make up the sample. So, that solves a little bit of the problem with representativeness, but again, you can never eliminate this selection bias problem with these non-probability convenient samples. All right, so now that we've talked about those, let's talk about experiments a little more. Last week, we said this classical randomized experiment is kind of the gold standard for establishing causality. It allows us to check all 3 boxes, covariation, time order, ruling out alternative or spurious explanations. And because of that, this makes these different from observational studies. But why did we say that their difference? What, related to the time order thing in particular, why are experimental methods different in terms of what the researcher is doing? Anybody remember? Yeah, James.
Observational studies are just looking at data. Experiments,
Yeah, well, they're both looking at data, right? Data is just information. But I think what you mean is that with the observational study, we can think of those as just a snapshot in time, right? We can't truly establish that one thing happened before another if they were both measured simultaneously. Whereas in the experiment, it's the researcher who has control over when the treatment or stimulus or the independent variable is administered. Yeah, so we said that the classical version usually takes place in a lab setting. We said that this leads to high internal validity, meaning we're pretty sure about the causal inference we're making, but only in the setting of the experiment. Doesn't necessarily mean that it generalizes to the broader real world. And that creates some concerns about external validity. But a lot of times in political science, we make the other trade-off. We conduct our experiments out in the real world, potentially sacrificing some internal validity, but enhancing generalizability and external validity. So we looked at an example last week of a field experiment that was conducted in China using these online forums where citizens can go and post requests or complaints to local government officials. You read and learned a little bit about these things called natural experiments, which we'll look at here in a minute. But I mentioned here, these aren't truly experiments in the true definition of the word, because they rely on nature administering the treatment rather than the researcher. We'll talk more about what that means here in a second. And then the other main type of experimental method that's becoming increasingly prevalent in political science is the survey experiment. And this is largely because of technological innovations. Online platforms like Qualtrics, SurveyMonkey, these make it really easy to randomize things and administer experimental treatments embedded in an online survey. So, these are tools that you can potentially use. They're really not that hard to program, and we frequently conduct these even on non-probability online samples. Right, and like I said, all of this just gets to the big point that in observational studies, the researcher doesn't have any control over the application of the independent variable, whereas in the experiments, the researcher does. Okay, so I mentioned a minute ago that natural experiments, these aren't technically experiments in the truest sense of the word, because the researcher is not the one administering a treatment. And because when it comes to things like randomization, we have to make some big assumptions, right? So an example of one of these that not necessarily a lot of political science looked at, but a few studies I know did. After the earthquake in Haiti happened, the way that damage from the earthquake was spread out throughout the country was essentially as if random, right? So it didn't, it wasn't certain parts of the country or certain parts of the capital city that were damaged and others weren't. It was randomly spread out. So we can think of that as an as if random treatment. And because of that, said, researchers were able to look at things like how that affected people's attitudes of the government, right? If you were in an area that was, we can say, treated with the natural disaster, what did those people's attitudes look like compared to those who weren't affected by it? And if we assume that randomization happened, it takes care of all of those other controls like we talked about last week, right? So in this article that I cite here on the screen, the authors explain that the rapid onset disasters like the Haitian earthquake, they act as natural experiments in that for a brief moment, they quasi-randomly assign a large segment of the population to internal displacements. Right, and then another example of a quasi-experiment or a natural experiment that you read about in the textbook was Dr. Susan Hyde's study of international election monitoring in Armenia. She conducted this this study using a quasi-experimental design around the 2004 Armenian presidential election. And she made the case that this was functionally equivalent to random assignment. What happened was poll watchers were sent to polling places, picked arbitrarily from a list. So we had a whole list of all the polling places in the country. People were arbitrarily assigned to go monitor them. The people making the assignments had no knowledge of the villages they were selecting. People working at the polls in these villages had no knowledge of whether or not a poll worker was going to show up until they actually did. So we can think of this assignment as functionally equivalent to random assignments, even though the researcher herself had no control over it. She was looking at this after the fact. And another key point here is that, natural experiments, they do allow us to make some stronger causal inferences sometimes, but a lot of times they just require luck, right? So we can't, it's not like going into the lab, planning to conduct an experiment, and then conducting it. We have to wait for the treatment to take place. We have to assume that the treatment was randomly administered. And then we have to be able to find these things. So again, it takes a lot of creativity, a lot of luck, but if you can find a natural experiment, it sometimes makes for a good contribution to the literature and a more exciting publication, I guess you might say. All right, so that's one type in addition to that lab version. And then the other type we mentioned was the survey experiments. I said a few minutes ago, the way a survey experiment works is you just embed an experimental manipulation in a larger, generally online survey. And because of random assignments, there's less of a concern about using a convenience sample. It doesn't eliminate the concerns, but there's a little less concern because we're just looking at average treatment effects between different groups. And when we're doing that, what we usually care about is just whether or not the effect was bigger or smaller, not necessarily about the effect size itself. So going back to Amazon's Mechanical Turk platform, again, the consensus around this is starting to change a little bit. But a lot of studies from like 2012 to 2016, they pointed out that samples drawn on this platform tend to replicate experimental findings from other political science studies that were conducted on more representative samples. Like I said, that's because we're really just interested in effect sizes and the direction of the effects. So if you were programming one of these, the way it would work is you would design a survey. Everyone who you pulled into the sample or who selected into it online decided to click the start button. They're all going to start the survey. They're going to answer a series of common questions that everyone gets. And then at some point in the survey flow, there's going to be a break. And we're going to randomly assign people to go in usually at least 2, sometimes as many as 10 different directions. Some of them are going to be randomly assigned to a control group that maybe receives no information. And then some of them will be assigned to one of the manipulations or the treatment groups. Treatments can, in a survey experiment, usually involve altering how information is presented to people or altering what sorts of images they see. And then we control, after everyone resumes the survey, they answer the same common outcome question. We compare across those different groups, just like we would do in a lab setting. So I'm going to talk very briefly about 2 different types of survey experiments. The one that used to be more common, and again, this has more to do with just advancements in technology than anything, but a lot of earlier survey experiments relied on what we call vignette treatments. So people just read something, maybe a couple sentences, maybe a paragraph. Maybe we've altered the information in like a mock news story that we ask someone to read. So everyone's going to read a similar vignette, similar statements with keywords or phrases manipulated or randomly altered. So in one of these vignette survey experiments using a non-probability sample from the Amazon's MTurk platform, I published this article with Dr. Tiffany Barnes at the University of Kentucky, and we wanted to know how politicians' sex and voters' political ideology affects how they respond to different types of scandals. So as you can see, not a ton to read, just a couple of sentences. But within this, we've manipulated key pieces of information. We tell everybody a U.S. representative is up for re-election and that either his or her, right, that's part of the treatment. We alter that information. His or her term has been relatively unremarkable, except for, here's the other treatment, a corruption or sex scandal. That's all we really tell them. And then people who were in the control group, they didn't receive the scandal treatment. They simply read that a representative was up for re-election. And then we ask everyone, how likely would you be to vote for this, hypothetical representative in the upcoming election, right? So 2 treatments, politician sex and the type of scandal. And this creates what we call a 2x2 factorial design. So if we have, one set of treatments that's politician sex, one set of treatments that is comprised of 2 different types of scandals, multiply that together for 4 possible combinations of treatments that we can compare to those control groups. So that's one. And then the other type of experiment that's becoming more common is what we call a conjoint experiment. So here, what we do is we're going to randomly vary a whole series of attributes to create different profiles. And one of the common criticisms of the previous type we looked at, the vignette experiments, is that even though we're administering a treatment, when we start comparing average treatment effects, looking at outcomes, we can never be fully certain what it is in that set of information that respondents are, responding to. Are they more concerned about the politician's sex? Are they more concerned about the scandal? Do they make assumptions, discount certain things? We just don't know. But with these conjoint experiments, when we can have lots of different attributes, lots of different treatments, we can be a little more certain in whatever the key piece that we're interested in. So we'll create these different profiles. Again, we'll look at an example here in a second. And then maybe we're going to put 2 profiles next to each other and ask the respondent to pick which one of these hypothetical candidates would you vote for? Which of these 2 policies would you prefer more? This type of experimental design actually originated in market research. So, market researchers were able to see what consumers really care about. Do they care about the price, the packaging, right? We can create these hypothetical profiles for different products that people would buy and then ask them, which one would you be more likely to pick up off the shelf? But we can do the same thing with, like I said, policies and candidates. And what this allows us to do is to examine the independent effect of each of those attributes that we're looking at on a given outcome. Instead of average treatment effects, we can think of these as average marginal effects. Nick Carnes and Noam Lupu, they've been looking at this question of whether or not voters dislike working class candidates. Big observation, the working class is underrepresented in most democracies. Why is that? Is it because voters don't like them, or is it because maybe party gatekeepers are keeping them from getting on the ballot in the first place? So they conducted this conjoint online experiment in the US, in Argentina, and in Great Britain. And as you can see here, this is an example of what the profile in the Great Britain experiment might have looked like. So, they first start off by manipulating the politician's sex by using names, common English names, John and Jane, same last name. And then they manipulate whether or not the hypothetical candidate is a business owner, so someone from a white collar background, or a factory worker, a working class blue collar politician. We go on, we see that there's information manipulated about their education, so we can make sure people aren't assuming that working class individuals don't have college educations. We can account for that. In this survey, they manipulate partisanship, ties to things in the community, all of this stuff. So they create these, these hypothetical profiles, present 2 at the same time, say which one would you be more likely to vote for, which one do you think is, more qualified, which one's more likely to respond to their constituents, all these things. And then just using really, really basic regression analysis, quite simple actually, we're able to see the effect of each of these attributes relative to some baseline while accounting for everything else. So what we see up at the top is that voters, when it comes to vote choice at least, they don't punish the working class candidate. We see no difference in the probability of voting for someone depending on whether they have a business background or a factory worker background. And really, when we look across countries, the only place where we see major differences is in political experience. And this was only manipulated in the Argentina experiments, but it's probably no surprise voters prefer candidates who have more political experience to none. And then we see some partisan differences emerging in the Argentina experiment. But by and large, this suggests that voters don't dislike working class candidates. They're just as likely to vote for them. Okay, so that gets us into talking about some more survey research stuff. I just want to briefly talk about questions in surveys, how to write them, how to write good questions, before we do a quick little activity that'll help us practice for Lab 3. So well-designed survey questions, we're going to assume, there's debate about this, ontological and epistemological debates. We're going to assume that survey questions allow us to measure people's attitudes, beliefs, and behaviors, usually using some sort of quantitative scale, quantitative measurement. So what are the assumptions required here? I'm just going to go through these kind of quickly and ask clarification questions if and when I think they're needed. But we have to assume everyone understood the question in the same way. And again, there's big debate about this, particularly when we are conducting cross-national analyses where surveys are translated into different languages. Does the word democracy mean the same thing in people's heads if the survey is administered in French as opposed to if it's administered in Chinese? Right? So we have to assume that responses are comparable across all individuals in all contexts. And we have to assume that respondents can choose from the full range of possible outcomes. So when might some of these assumptions break down? I mentioned one of them related to language, but is there any other things that we can think of? Think about questions about democracy. Even if we assume everyone understands it the same way, do we have to be cautious interpreting attitudes about democracy if the survey was administered in the US versus in Egypt, and why? Mainly because we have to question whether or not people in the authoritarian context are going to tell some supposedly anonymous survey researcher their true attitudes about the regime, right? It's not an open political culture. Yeah, so like I said, we sometimes get into trouble when we're doing cross-national research in multiple languages, and related to the idea that the full range of possible responses is out there. I mentioned this when we talked about measurement, but unnecessarily dichotomizing responses, these can affect causal inferences. A lot of times it's not so simple as people either completely agree or completely disagree. We need a range of options with things in the middle. Yeah, so those are more related to measurement, to inferences, in terms of what a good survey question involves. Obviously, it needs to be easily understandable, unambiguous, and this can be a problem, especially when people with PhDs in political science are conducting research. We often tend to assume that people understand concepts like ideology in the same way that we do. Not necessarily the case. So the questions should be clear. They should not be leading. They shouldn't be pushing respondents to respond in a certain way. You should avoid asking, don't you agree with this statement? Instead, say, how much do you agree or disagree with the following statement? Don't lead people to select one option. Don't provide unnecessary information that might prime the respondent to think about something else. And then the other thing we want to avoid is double-barreled questions. And this is kind of related to the clarity, the unambiguous piece. A survey question should really just include one question. It should be measuring whatever it is you're trying to create an operational definition for. So if you've got two questions in one, you ask people's level of agreement, you have no idea which of these two things the respondent is actually responding to. So the responses are effectively meaningless to the researcher. Okay, so I'm gonna skip over this stuff because it's not totally vital, but if you want to go back and review the slide in the recording later on, it's up here for you. And what we're going to do instead is spend the last 10 minutes talking about interpreting survey data. So this is what you're going to be doing in lab assignment number 3. You're just going to be interpreting some trends using data from the Latin American Public Opinion Project. So I want to do a little practice now, and then we'll do more practice when we meet for our next lab day on Wednesday the 24th after spring break. All right, so in this data, Latin American Public Opinion Project asked respondents about their trust in a variety of different political institutions, one of which is political parties. So all these questions have the same response scale. And they'll ask people on a scale from 1 to 7, where 1 means absolutely no trust and 7 means a lot of trust. Tell me how much trust you have in political parties in this case. So this is the data from Brazil between 2009 and 2010. It's the 2010 wave of the LAPOP study. And as we can see here on this histogram, the variable is what we're measuring. It's trust in political parties. The level of measurement we can think of as being ordinal, right? It's not quite a ratio or an interval level. It's truncated between 1 and 7. We can't necessarily assume that the space between 1 and 2 is the same as the space between 5 and 6. So it's an ordinal scale measuring trust in political parties. And as you're interpreting these things, I always just encourage everyone to look at kind of 4 main things. You want to see what's on the x-axis. In this case, it's the different response options to that question, 1 to 7. What's on the y-axis? In this case, it's the percentage of respondents who picked each one of those response outcomes. Look at the title to see what the data corresponds to. And then I usually tell people, look at the shape of the distribution. So a lot of times you're just most interested in whatever the most common outcome is. And here we can see that the majority of Brazilian respondents in this survey indicated that they had absolutely no trust in political parties. Only a very small percentage of participants said that they had a 6 or a 7, a lot of trust. So what we'll end with is this brief little participation activity based on similar data. Again, this is from LAPOP. I would like everyone to look at this figure here and then write what we call an intuitive interpretation. And before we get out of here, I'll give some pointers on what intuitive should mean. But the question here is, please indicate the degree to which you agree or disagree with the following statement. The government should implement strong policies to reduce income inequality between the rich and the poor. We've got the same response scale. It's just this time 1 indicates strongly disagree and 7 indicates strongly agree. So take a few minutes, look at everything that's on here based on what we just said, write down an intuitive interpretation and hand those in to me. If you're on Zoom, you can email your responses to me. So long as I receive them by 10 a.m., you'll get credit for this assignment. And then before we get out of here, like I said, I'll give us some pointers on what a good interpretation should look like. in the last couple minutes that we have, let's talk about interpreting. What you were writing, like I said, was mainly just for engaging your participation in class today. But you would say something like, this figure is showing the distribution of responses in Argentina in 2018 to a question about agreement that the government should use its policy options to reduce inequality. The variable that we're interested in is, essentially support for government involvement in reducing inequality. And then you would start going on to describe what's going on here. So always mention the scale. This got some people into trouble on lab number 2. You always want to give the numbers context, right? A 4 is completely meaningless out of context. So here you would say that responses to this question range from 1 to 7, with higher values indicating more agreements. We see that on the y-axis is the percentage of respondents in this survey who selected each one of these possible response outcomes. And then the other thing that we see is the distribution, right? The mode, or the most commonly selected answer, was that people strongly agree, a 7 on this scale, that the government should implement strong policies to reduce inequality. So, that's what I mean when I say intuitive interpretation. You should situate your interpretation in the data itself. We're not necessarily asking for an explanation of why this is the case. We just want to be able to explain the figure in the data to someone who hasn't read the code book and who hasn't been trained in statistics. So, after you reread your interpretation, ask yourself, am I answering, what's the question measuring? What's the scale? What's the range of the scale? What do high and low values mean? If we're interpreting a figure, what's the shape of the distribution, or the most common value? What's the x-axis represent? What's the y-axis represent? So like I said, just keep all that in mind as you start getting into these later lab assignments, because a lot of them are going to ask you to provide an intuitive interpretation of some sort of statistic or visual representation of data. All right, so we're essentially out of time. I've got some notes on lab 3 up here. Like I said, we'll meet again on Wednesday, March 24th after spring break to do a lab day like we did last time. I'll do a brief tutorial, and then I'll be here for you to work on it and ask questions if you want to do that. And then Friday, March 26th will be our next lecture here 2 weeks from today. So in lab 3, you're going to be calculating some descriptive statistics by hands. And then in part 2, you'll be working with survey data from LaPop. Just follow the instructions very carefully. Pay close attention to that video online about how to make a histogram and interpret it, what it depicts, like we just did. All right, have a great spring break next week, everyone. There's no assignments for next week, so you can just, take the time off to relax, and I'll see you in a couple weeks. Yeah.
Are we actually getting a spring break?
You get a day of spring break. We're calling it spring break. It's next Friday. I don't know what other professors